Welcome back to our little tutorial series. In this episode, we are giving the combat system a nice upgrade with pushback and a Flashhit effect, because getting hit should probably feel a little more dramatic than it does right now. We will also create some really nice health and experience displays, so the project not only feels better to play, but also looks much more polished. So this episode is all about stronger feedback, cleaner visuals, and a combat system that feels much more satisfying. Let's get started. So, as our first topic, let's level up our combat system a little bit. Right now, when we hit an enemy, nothing really happens. There's no feedback, no reaction, no health bar. It's basically like hitting a ghost. Not very satisfying. So we're going to fix that. First, we'll add a knockback effect. That means when we hit the enemy, he actually gets pushed back. Simple and clear. Then we'll add a small hit flash effect, so the enemy briefly flashes when taking damage. Just to make it extra clear, yes, that hit landed. On top of that, we'll introduce a short stun after every hit. Nothing crazy, just about half a second, but enough to make combat feel responsive and controlled. And finally, we'll give the enemy a proper health bar. Right now the player has one, but we're actually going to redesign the player's health UI anyway, so the enemy can use the current version for now. To make all of this work, we'll need a few functions. Apply knockback. Knockback. Is knockback active and flash hit? Let's build them step by step. Now let's take a look at the apply knockback function. This function receives two values, the position and the knockback strength. With the given position, we can calculate the direction from the player to the enemy. So what does normalized do? It takes a vector and sets its length to exactly 1 while keeping the same direction. And once we have the direction, we can calculate the velocity. That's where the strength value comes in. It basically scales how strong the push will be. For this to work, we still need to create a few variables. One for the base movement speed and one for the knockback velocity. This way, we can separate normal movement from the external force applied by the hit. On top of that, we also need a small delay for the knockback. Otherwise, it would stop instantly, and that wouldn't feel very good. For now, let's just set the value to 600. We might tweak it later depending on how it feels in the game, because as always, combat needs to feel right, not just work. Alright, we've got an error here. Let me quickly check that, because that doesn't make any sense. Okay, of course, just a small typo. That's my weakness sometimes, but hey, easy fix. Now we're going to call the apply knockback function right where the enemy receives damage. And of course we pass in the two required variables that the function needs. Simple as that. Alright, so the second variable is a global variable. That means we need to grab it from our globally defined script. And looking at it right now, I really don't like how I named that script. So let's clean that up. Inside the global script, we definitely need a variable for the player's strength. Let's just set it to 200 for now. Now we'll jump into the project settings, because I'm used to writing global names in uppercase. Also, the script name and the name inside the global autoload list shouldn't be identical. So we'll rename the script and adjust the global name as well. That already looks much better. And now we can access the variable inside our function using this command. Alright, so with that small script name change, we may have created a tiny problem. Let me show you, because now everywhere we referenced our global script before, we've got errors. The engine can't find it anymore, which makes sense. Now, the classic approach, and honestly the painful one, would be to manually fix every single reference. But we're not doing that. Here's the trick. We can simply highlight the old global name and replace it everywhere in this script at once. One change, applied everywhere. Much faster, much smarter, and way less annoying. To do that, we first select our global name, then we press Ctrl+D, and that lets us select the next occurrence in the script. We keep pressing it until all references are selected. Now we've got multiple cursors active at the same time. With the arrow keys, we move the cursors to the right position, and then we can edit all of them simultaneously. One correction, applied everywhere. Super handy, and definitely a time saver. Let me quickly speed up the video while I update all those globals. Alright, that's done. Now let's quickly test it. We'll run the game, and no errors. Very nice. Perfect. Now we can get back to our knockback system. Alright, inside this function we first define the knockback decay. Here we're basically saying as long as the velocity is greater than 0, it should gradually move back towards 0. And this is exactly where we use the decay value we defined earlier. If the knockback feels too strong or too slow later on, we can always tweak that value. Now next, we're adding a stun state. So once the knockback velocity drops below 0.1, we set the enemy status to stunned. For that, we'll need a new variable, which we'll define in a second. Now let's talk about the animation. We don't actually have dedicated stun sprites, so we're going to improvise a little bit. We'll take these two existing frames, duplicate them and loop them quickly. That creates a simple shaking effect. And we'll also increase the animation speed to 8 frames per second. That gives us a slightly faster shake and makes the stun feel more tragic. If we run the animation now, you'll see the little guy trembling. Perfect. Now we just need to trigger that animation when the stun state activates. And finally, we add the timer to control how long the stun lasts, because without the timer, he'd be stunned forever, and that might be a bit too dramatic. Next, we create a small function to check if the knockback is active. This function simply returns a boolean. All it does is check whether the knockback velocity is greater than 1. If that condition is true, the function returns true, and once the value drops below 1, it returns false. Simple and effective. Now let's add the Flashhit effect. This one is actually pretty easy. We take the sprite and use the modulate property. With that we can temporarily change its color. In this case I'll use red. The nice thing is, the editor even shows the color preview. Next, we wait a short moment. Instead of creating a separate timer node, we can simply start the timer directly inside the function and wait for it to finish. After that short delay, we reset the sprite color using modulate again. For the flash duration, we'll use 0.1 seconds. Just enough to clearly see the hit without being distracting. Alright, now it's time to bring all these functions together. First, the flash hit is easy. We can simply trigger it right here when the enemy receives damage. The knockback, however, is a bit more complicated. To make it work properly, we actually need to restructure our movement logic. So for that, we'll create a new function. Inside this function, we'll move all the basic movement behavior of the enemy. That includes the base velocity, the random movement direction, and the idle walking logic. This way, everything related to normal movement is cleanly organized in one place, and that will make it much easier to integrate the knockback system. Next, we check whether the enemy is idle or chasing the player. Depending on that state, we set the velocity and control the behavior, so the enemy will either move randomly while idle or actively chase the player. Now we also need a variable to check whether the enemy is still alive. We'll place this variable in the global script so we can access it from anywhere. Here we set the variable to false because this is the point where the enemy dies. Then, inside the ready function, we initialize it by setting the enemy to alive at the start. After that, we call the knockback function inside the physics process. And while we're here, we'll slightly restructure the logic. Now everything depends on whether the enemy is stunned or not. If the enemy is not stunned, the normal movement logic runs, and inside that structure we also integrate our knockback handling along with the move and slide call. To be honest, this solution isn't exactly clean or super professional, but that's mainly because we've been continuously building on the enemy code step by step. So at this point, a few things are a bit patched together. For the next enemy, we'll use a completely different approach, and yes, that will also be covered in this tutorial just a bit later. But for now, we still need to add the stun timer. That part is absolutely necessary. So here we connect the timeout signal. And once the timer runs out, we simply set enemy stunned back to false. Now let's test what we've got so far. Okay, yeah, that doesn't look great. The knockback kind of works sometimes. The stun isn't really working yet the way it should, and the overall movement still feels a bit off, but we'll fix that. Like I said, when old code keeps getting extended over time, you eventually have to go back and clean things up a little, so stick around, we're going to fix all of these issues. Alright, now we're going to quickly go through all the movement functions. The goal is to make sure they only run in the correct states. Let's start with random direction. Here we just need to make sure that this doesn't run while the enemy is chasing the player. Pretty simple fix. And of course we also need to update all enemy alive checks to use the global variable, since we moved that value into the global script. And while we're here, we'll also make sure again that this logic doesn't run during player chase. Next, we'll quickly adjust the time interval to 0.5 seconds. Everything here looks good. Now the same thing here. We switch enemy alive to the global variable, and we also make sure that the enemy is not stunned. Otherwise the animations would still play during the stun. And here again, same adjustment. We just make sure the enemy isn't stunned. That way the animations behave correctly. Let me quickly check what this timer is doing. Okay. This one simply controls whether the enemy can receive damage or not. Alright, now let me update all these enemy alive checks to use the global variable. I'll speed up the video while I go through them. And finally we can delete this local variable here, since it's now defined globally. Let me also add one small safety check so the knockback only works while the enemy is actually alive. Alright, let's test it again. Yes, that's exactly how it should look. The enemy gets pushed back, the flash hit works, and everything feels right. Perfect. Alright, that's it for our movement and knockback improvements. Before we move on, I'm going to rename a few sections in the script, just to keep everything organized. Once that's done, we'll start working on the enemy health bar. For that we create a new function, and for the health display we can simply use a progress bar node. First, let's resize it a bit, so it fits nicely below the enemy. We also don't need to show the percentage value, so we'll disable that. Now let's implement the logic. We already have the variable we need, the enemy's health, so we simply set the value of the progress bar equal to that variable. Then we add a small condition. If the health is greater than or equal to 100, we hide the health bar. That way the health bar only appears once the enemy actually takes damage. So as soon as the value drops below 100, the bar becomes visible. And of course, don't forget to call the function. I forget that all the time. Alright, let's test it. And there we go, the health bar is working. The last thing we'll do is change the color to green, just like the player's health bar. And after that, we'll remove the player's old health bar as well. One thing I noticed earlier is that the enemy gets knocked back before the sword actually hits. That happens because of the animation delay. The hit is registered immediately when we press the attack button, but the animation itself is slightly delayed. So visually the knockback happens a bit too early. To fix that, we'll add a small delay to the player's attack. We'll do this using a timer. Let's set it to 0.15 seconds, so the hit only registers once the animation has reached the impact frame. So here we simply wait for the timeout, and then we set the global hit variable to true. Now let's test it again. And there we go. The knockback now happens exactly when the sword actually hits the enemy. Much better. It's a small detail, but it really improves the feel of the attack animation. Now let's also change the health bar to green. That already looks much nicer. But there's one more issue I noticed earlier. Right now, we're actually taking damage from our mushroom. That's an interesting bug, and we'll fix it right away. So let's dive into that next. Alright, to fix this, we go to the function where the player receives damage. Right now we only check if the player is alive, but to be safe, we'll also add a condition that the enemy must be alive as well. Next, we introduce another variable, which we'll define as a global variable. This one checks whether the player is within the enemy's attack range. So let's add that variable to the global script. Now, we need to make sure it gets triggered inside the enemy script when the player enters the detection area. So here we are, and we'll simply add this global variable to both detection area signals. For now, we'll just leave the local variable player attack range in place. It shouldn't interfere anymore. Alright, time to test it. Okay, the enemy still deals damage. Good. And when we get close to the mushroom, we no longer take damage. Perfect. Now, this solution is definitely a bit quick and dirty, but it works exactly the way we want it to. Finally, we'll also give the player a red flash hit effect, just like the enemy. For that, we can simply copy the existing function. In this case, we even have an animated sprite with the same name, so we can actually leave all of this exactly as it is. That should work without adjustment. Let's just quickly check where we call the function. Right here, we triggered the enemy attack flash hit. Alright, quick test. And there we go. Now the player also flashes red when taking damage. Very nice. And with that, we're finally done with all the player combat improvements. Next up, we'll start working on our new health bar and the experience bar. Now, for the player UI, including the health bar and the experience bar, we first need a new node. So let's choose user interface. Now we need to build a structure that allows us to adjust the UI properly and keep everything organized. So for this part, just follow me closely while I add all the necessary nodes, and please make sure to keep the full structure exactly the same as mine. Later, I'll explain what each node actually does, which parts it affects, and how we're going to use it. And of course, don't forget to save the scene. I'll call this one Player UI. After that, we'll continue by adding the rest of the required nodes. There will be quite a few this time, so just stay with me and copy the setup step by step. Alright, here's what we need. We'll start with a panel. Inside that we add an HBox container and a label. The HBox container will split our panel horizontally. The label is simply there for the text. Then we definitely need a texture progress bar. That's important because this lets us use our own custom texture, the one I'll provide for you to download and use, and we actually need 2 of those. We'll see a bit later why we need 2 of them. Then we also add a couple of texture recs for the small icons that show our collected mushrooms and essences, and on top of that we need another label so we can display the amount. Now let's give all of these proper names. Next, we'll create a folder for our graphics. If you haven't done it yet, go to itch.io by simply using the link in the description. Download the graphics pack and place the files into the folder we're creating here. That way, we can easily access them and start using them in our UI. Alright, now we have our graphics ready. We've got 2 experience bars, 3 health bar textures, and the 2 small icons. Next, we select our panel and assign the theme we created in a previous tutorial. That was the one from the last menu tutorial. Once we apply this theme, many important settings are already configured for us. For example, the labels already have the correct font and font size, so this theme works really well for our UI. Now let's move to HP bar 1 and define the textures. First, we set the under texture. That's the dark one. It's basically a very dark background that looks like an empty glass container, slightly transparent. Next, we set the progress texture. For now, we'll use the orange HP bar. I'll show you later why we're using this. Then for HP bar 2, we also define the progress texture, but this time we use the red version. Next, we add the icons for our mushroom fragments and our essences. The numbers you see here are just placeholders for now. Later, we'll fill them automatically through code. Now we need to adjust the size and layout. This part can be a bit tricky and it's not exactly self-explanatory. There are a lot of different options, and finding the right combination sometimes takes a bit of experimenting. So let's tweak the layout a little and adjust the sizes until it looks right. For the health bar, we also set the vertical alignment to center. That already looks much better. Next, we adjust the icons so they don't get stretched. We want them to keep their original size. And after a few small adjustments to the layout and scaling, there we go. That looks really nice now. Now we simply duplicate this whole setup so we can create a similar experience bar. If you already feel confident with the UI system, you can absolutely experiment a bit. For example, you could combine the HP bar and the experience bar into a single layout, or try out a completely different design. But for this project, I'm going to stick with this setup. It fits really well with the overall structure of my game. Next, we center both UI elements so they sit nicely in the middle of the screen, one at the top and one at the bottom. For the experience bar section, we can remove a few things. We only need one progress bar, so we can delete the second one. We also don't need the icons here, so those can go as well. What we keep are the labels and a single experience bar. Now we just need to replace the textures because we're using special graphics for the experience bar. The first label will simply be the title, and the second label will later display the player's level, which we'll read directly from our script. Alright, after saving the scene, we jump straight into the player scene. Here we need to implement our new UI. First we add a canvas layer node to the player. A canvas layer keeps UI elements fixed on the screen, so even when the player moves, the UI stays in the same position and doesn't move with the character. Inside this canvas layer, we now instance our player UI scene, and as you can see, it already appears on the screen, but if we run the game now, you'll notice that the size and position still aren't quite right. So there are a few things we still need to adjust. To fix this, we'll jump into the project settings, and while we're already here, let's quickly update the main scene. At this point it makes more sense to start the game from the main menu. So we simply set the main menu scene as the main scene of the project. That way we can start the game from anywhere. Next, we go to the window settings and reset the zoom factor here. This allows us to control scaling only where we actually need it. But if we run the game now, you'll notice that everything looks wrong. That's because the project was previously relying on that setting. But don't worry, we'll fix it quickly. First, we adjust the camera. Here we simply set the zoom back to 3, just like we had before. That already looks much better. We also need to make a small adjustment to the main menu. First, we fix the zoom of the background image. This blue rectangle here shows us exactly how much of the screen is visible at our current resolution. So now we simply adjust the background until it nicely fills that rectangle. Once the background is placed correctly, we also scale the main menu elements so they fit well into the scene. Let's do a quick test, and yes, that looks good now. Finally, we do something similar for our canvas layer UI. We slightly increase the zoom factor, center the layout, and make sure everything fits within the visible screen area. Now let's test it. Perfect. The UI now appears exactly where we want it. And as a final touch, we can add a little transparency to the UI panel. That way, you can still see the game clearly behind the interface. And here we have our final result. Honestly, I really like it. What do you think? How would you do it? Would you change anything? Let me know in the comments if you would build it differently or if you have ideas for improvements. Maybe we'll adjust a few things in a future update. Now let's talk about the health bar. As you can see, we have two different layers here, the red one and the orange one. We can enter a test value here just to preview what the result will look like. Later on, we'll control all of this directly through code. The idea behind these two bars is pretty simple. The red bar can slowly regenerate up to the orange bar automatically. But if we want to heal completely, we'll need to eat mushrooms. So basically, this gives us two health values. One is the current health, and if that reaches 0, the character dies. But at the same time, part of the health can regenerate automatically, filling the gap between the red bar and the orange bar. And if we want to restore everything, we'll need to use mushrooms. For the experience bar, we can also enter a temporary value just to see how it looks. And yeah, that looks pretty nice. And with that, the combat feels better, the UI looks better, and the project takes another big step forward. Thanks for watching, and I will see you in episode 10.